Rethinking the Past, Post-Glacial Flooding and the Lost Rivers of Britain. Introduction. Welcome to Rethinking the Past, where we move beyond myths and focus on measurable data. In this episode, we journey through Britain's forgotten waterways, ancient river systems long erased from maps but preserved in geological and LiDAR record. These rivers fed not by melting glaciers but by vast discharging aquifers under the ground, transformed post-glacial Britain into a complex network of water highways. As we stand here at Stonehenge, symbol of prehistoric ambition, we are reminded that our ancestors didn't just build monuments. They navigated rivers, managed water, and lived in landscapes far wetter, broader, and more dynamic than we've ever imagined. The conventional story claims that sea levels stabilise just after the Ice Age. But what if that's wrong? What if the water kept flowing, not from ice, but from beneath our feet? Over the next 30 minutes, we will unveil the mathematical and geological proof that changes everything. We'll revisit Doggerland, dissect sediment records, consult LiDAR scans, and finally understand why Britain's earliest engineers relied not on carts and trails, but boats. Chapter 1. The Myth of Stable Sea Levels. For decades, geological orthodoxy has insisted that sea levels stabilised shortly after the Ice Age. Glacial meltwater, they claimed, did most of its work by 8,500 BCE. Once the ice retreated, rivers simply settled into the channels we know today. But recent sea level data boreholes has changed the narrative. In fact, it blows it apart. The Wadden Sea data by Hijma and Cohen, based on 700 radiocarbon dated cores, shows that from 6,850 BCE to 0 AD, sea level rose by almost 10 metres, not in past sudden pulses, but in a steady, consistent rhythm. These findings are reinforced by the Doggerland reconstructions published in Nature magazine, which used seismic data to show sediment layering beneath the North Sea. It too reveals a persistent sea rise over thousands of years, long after glacial melting had ceased. The Meijiles dataset, developed right here in Britain, adds another layer. It shows a similar steady sea level rise, but also tracks changes inland, how rising water reshaped river terraces and pushed aquifers to their limit. Combined, these datasets form an irrefutable pattern. Britain's flowing hydrology didn't stabilise after the Ice Age. It continued, dramatically and continuously. This means something profound. The maps of Mesolithic and Neolithic Britain, those tidy outlines of land and sea, are incomplete. They miss the reality of a soggy, dynamic landscape in which rivers were swollen, floodplains broad, and human settlements adapted to watery instability. When we look again, not with assumptions but with data, we see a different Britain. Not the landlocked island of textbooks, but a mesh of wet corridors constantly evolving under the pressure of flowing waters. This is the true starting point of our prehistoric journey. Chapter 2. Where did the water come from? So where did all this water come from if the glaciers had already melted? The traditional model has no answer. It clings to the idea that glacial remnants on uplands somehow kept feeding the seas. But paleoclimate data from Greenland ice cores and pollen records from Europe tell a different story. By 8,500 BCE, global temperatures had already reached the Holocene thermal optimum. Glaciers were gone. Mountaintops were bare, yet sea levels kept rising. How? The answer lies in the earth itself. Trapped beneath Britain's surface were massive volumes of groundwater locked away during the ice age under pressure and frozen crust. As the planet warmed, the permafrost melted. Aquifers began to collapse. The land didn't just dry out, it began to drain. This discharge wasn't dramatic. It wasn't a flood or tsunami. It was slow, steady and relentless. Water seeped from hillsides, springs bubbled where there were none before, and rivers swelled beyond their natural banks. The landscape was bleeding. Imagine a sponge, soaked and compressed. Now release the pressure. The water doesn't gush, it oozes. This is what happened beneath our feet, and it continued for thousands of years. These vast volumes of groundwater flowed into the rivers and eventually into the sea. They pushed Britain's sea level higher, long after the glaciers had vanished. They transformed modest streams into transport arteries, and they turned valleys into floodplains. Once we understand this, everything changes. River systems weren't passive channels. They were engines of transformation driven by aquifers the size of nations. And Britain's Mesolithic story wasn't about survival on dry land. It was a saga of thriving on water. Chapter 3. Mathematical proof. It's one thing to speculate, it's another to calculate. So we turned to the numbers. We constructed a model using 3 data sets: Hijma and Cohen's Wadden Sea Core, the Doggerland seismic records, and Langdon's Meijiles reconstruction. All 3 tell the same story. But could we prove it mathematically? We took sea level rise over 500-year intervals and compared it with natural discharge expectations, roughly 0.885 metres per 500 years based on pre-industrial rates. The results were staggering. For instance, between 10,000 and 10,499 BP, the sea level rose by more than 103 trillion gallons of fresh water, nearly 30,000 times the expected output. That's not rainfall, that's not glacial melt, that's inland groundwater discharging through rivers swollen to proportions we can barely imagine. This table doesn't theorize, it proves. It shows when the discharge peaked, how quickly it declined, and how that aligns precisely with the end of megalithic construction. Monument transport stopped when rivers dried up. Between 14,000 and 3,000 BP, the sea level rise constantly outpaced natural runoff from 5 times to 29,000 times. This is not a margin of error. It is a redefinition of Britain's ancient water cycle. We reverse engineered river flow volumes using verified sea level data, and what emerged was a Britain covered in water highways. Floating stones, migrating cultures, seasonal surges, all mathematically grounded in real measurements. Yet this isn't a theory anymore, it's a proof, a remapping of Britain's entire prehistoric hydrology, 1 gallon at a time. Chapter 4. Britain as a water world. To understand the Mesolithic landscape, we must forget the Britain we know. Picture instead wide valleys brimming with water, floodplains permanently saturated, and boats drifting across areas that today grow wheat or house suburbs. Evidence from carbon-dense peatlands supports this. Britain holds the highest concentration of peatland in Europe. Modern maps show 12% still classified as deep peat, but modelling suggests that during the early Holocene, more than 60% of the British Isles was covered in saturated soils. This is more than a statistic. Peat doesn't form on dry ground. It forms under waterlogged conditions when decomposition slows and organic matter accumulates. The early Holocene was perfect for this. Warm temperatures, low-lying flood basins and unrelenting groundwater discharge. Macklin and Lewin's longitudinal studies back this up. They show sustained flooding in river systems across Wales, the Thames and the Severn. Not from rainfall, but from overflowing aquifers and hydrological instability. Rivers were not only deeper, they were wider. Multi-terraced valleys like those in the Teifi catchment didn't form in one dramatic surge, but from years of annual flooding and retreat. Settlements in these times weren't built along the edge of rivers, they were adapted to the rivers. Floating platforms, raised walkways and canoe culture defined daily life. Transportation wasn't by path or track, it was by water. This was a wet world, a floating Britain, and only by acknowledging this can we understand the scale and design of prehistoric infrastructure, from causeways to stone circles, all positioned with water access in mind. Chapter 5. The shrinking rivers of the Neolithic. But no flood lasts forever. Around 3000 BCE, something changed. The discharge tables show a dramatic drop in freshwater flow. The rivers, once mighty, began to shrink. This wasn't sudden, it was progressive, a slow drying that affected every corner of the Isles. As aquifers emptied, their input declined. River volume dropped, floodplains receded, and previously navigable channels became marshes or disappeared altogether. This change wasn't just environmental, it was cultural. The Neolithic saw a marked reduction in megalithic monument construction. The great stones stopped moving, not because of war or social collapse, but because the rivers could no longer carry them. For a society built on a water transport, this shift was catastrophic. What was once an advantage, access to floating networks, became a limitation. The drying rivers isolated communities. Supply routes vanished. Maritime engineering lost purpose. We see the shift in the archaeological record. Raised land settlements begin to appear. Long barrows cease. Ceremonial sites grow more static and insular, and new paths emerge, dry, trodden tracks replacing ancient water routes. Britain was drying, and its people were adapting. But in that transition, something was lost, the fluid connectivity that had defined the Mesolithic. The Neolithic is often seen as a period of great innovation, but in truth it was a time of adjustment, an effort to cope with the death of the water world. Chapter 6. The Thames Case Study. Nowhere is the story clearer than in the Thames Valley. Beneath the concrete and bustle of modern London lie layers of silty truth. Borehole records reveal up to 12 metres of alluvium, silt laid down by rivers that once dwarfed the Thames, we know. These layers aren't uniform, they rise and fall in bands that match sea level acceleration curves. In the early Holocene, the Thames flowed not as a gentle channel, but as a tidal estuary stretching deep into Britain. Discharge was over 3,700% higher than today. That's not a typo, that's a super river. Data from Langdon's Meijiles Model shows the groundwater influence on this region was extreme. Inland discharge, combined with tidal forces, created a fluvial engine that reshaped the southeast of Britain. It wasn't just a river, it was a corridor, a navigable highway that connected ceremonial sites, transport hubs and seasonal settlements. From Hornchurch marshes to Runnymede, the evidence shows aquatic adaptation, elevated trackways, timber jetties, water-aligned post holes. As the aquifers emptied and the river retreated, these infrastructures became redundant. What was once a grand artery became fragmented, isolated. Settlements that once faced water began turning inward, toward land, toward permanence. This is why the Thames must be seen not just as a geographical feature, but as a historical actor. It was a lifeline, a witness, and eventually a casualty of Britain's drying bones. Chapter 7. Welsh case studies. Across Wales the evidence repeats itself. From the Upper Severn to the Teifi, catchments reveal a story not of erosion, but of expansion. Valleys that today appear modest once held rivers 10, even 50 times wider. Take Caersus. Modern views show a sleepy meander, but beneath lie flood deposits metres deep. At roundabout, peat and silt core samples show flooding from at least 8,500 BCE. East Rudcarron's step terraces chart centuries of hydrological retreat, and Pant's layered floodplain tells the story of a river shrinking over millennia. These sites weren't anomalies. They were nodes in a network. Water connected them, fed them, defined them. The people who lived here weren't walkers. They were floaters. Traders, builders, travellers who moved not along but with the water. As the discharge waned, so too did their reach. The grandeur of the stone circles, often found beside now dry streams, made sense only when those waters were full. When rivers dropped, the society that relied on them had to reinvent itself. In Wales, where upland springs once fueled unstoppable flows, the silence of today's shallow brooks masks a thunderous past. Chapter 8. Final synthesis and legacy. So what does this all mean? It means our understanding of prehistory must change. The Britain of 10,000 years ago was not the land we know today. It was wetter, louder, more interconnected by water than any textbook admits. Rivers were not boundaries. They were bridges. Aquifers were not hidden. They were architects. They raised the seas, carved the valleys, and fed the networks that made monument construction possible. The megaliths, Stonehenge, Avebury, the lost henges of the fen, are not dry relics. They are water stations, their logistics made possible by boats and barges that no longer sail. And the decline of these great projects, it wasn't because of some mysterious collapse, it was hydraulic. The water disappeared, the boats stopped moving, the culture adapted, but the golden age had passed. With the post-glacial flooding hypothesis, we now have a model, not a theory, but a testable, repeatable and visual framework. It tells us when the rivers rose, how they fell, and what it meant for the people who lived along them. This is more than history, it's geology, hydrology, math, and most of all, it's truth. Truth buried beneath centuries of assumption, now finally rising to the surface.